Hello everyone, welcome to Codex Tech Rust Learning video blog. Today's video will be shorter than my previous videos. In today's video, we will be building a small HTML link parser utility. We will be using this utility for site map builder exercise. That will be the next one. This exercise is also from the Gophercises website, and as usual I will provide link to the actual Gophercises website as well as the GitLab where this exercise will be hosted. So let's get started with it. So starting with the cargo.toml file, so we have only one dependency in this case. We are using the scraper package. So this crate is, when I looked up, they have better API and it was up to date, so I decided to use it. So that is the only dependency. So in the main.rs file, let's start from the top. So I have these HTML documents directly embedded in this file, so I could read these HTML documents from the file system, but we already tried reading from the file system, so it was not really necessary. So instead of that, I just put those HTML documents, their text, directly in the main.rs file. So you can see this HTML doc1, so simple HTML, that's the simpler case, and then there is I guess a more detailed document in the HTML2. So we will be reading these links from the document. So that's the idea. We will parse the HTML, read the link, get the href from the link, and the text between that anchor tag, we have to read the whole text, extract that text out, removing any other tags that might appear inside that anchor tag, any extra spaces. So we'll have to clean up that HTML and create a structure, a link structure with href as one property and the text as another property. So as you can see in the HTML doc3, I have even a little bit more complicated design or structure. There are anchor tag, other tags, there are comments. So this is just to check that it will be able to parse this HTML and read those individual anchor tags. In HTML4, I have comment within the anchor tag. So in this case, we will want to make sure that when we extract the text, the comments are not there. So next, I will take the user input. So user can enter from 1 through 4 which document they want to parse, and if they enter any other number, then the idea is to break this loop. So when the user enters whatever number they want to pick for whichever document they want to parse, we will be calling this generate link after we do the matching on the user input. So call this generate links and pass the actual document text. So if we were reading it from the file system, we'll just extract the text out. This is where we have the main logic. So this is the generate links method in the parser.rs file. So we are bringing two structures or dependency on the scraper crate, HTML and selector. And this is the structure, the output structure format. So we will have link structure with href and text, those two properties for every hyperlink or anchor tag that we will find in that HTML document. So in the generate links, we will take the HTML doc string slice as an input, and then we are using the HTML module from the scraper and the parse document method. So it will parse the document and create the document object from that string, and then we are creating a selector tag. So this is selector parse method. So we want to select all the anchor tags. So once we create that, then we will just go through the document. So we have this document dot select. So basically we are running the selector that we created. It's like any CSS kind of selectors. So it will look for all those anchor tags, and it will read. So if we find any element with anchor tag, it will read that element. It will read the attribute href for that specific element, and then try to unwrap that string or the href attribute value, and then next what we are doing is, from that element we want to call the text method. Text method returns a text object. This will be all the text that is within that anchor tag or any other HTML element. Since it will return a text object, it also has the iterator properties like for any other nested tags. So we need to call some other method, for in this case I'm using fold, to then merge those separate text elements and create one big string. So in case of fold, we are initializing it with empty string, because if we look at the this method, so we need to pass left L and R. This is left and right. So first time L will be the initialization value, and next time L will be the previous value, and the right would be the next value. So we are just calling a string concatenation. So L plus R dot trim, because we have to remove all the spaces, so we don't want any spaces in the beginning or end of a string. And then we just add an extra string, and that we have to call trim and to remove the last extra space that we are adding. There were different ways to achieve this. The most simplest, I'll leave it this first option in there. So this is the simplest code, like text.collect, and it will join all those vector values and give you the final string. But we cannot remove extra spaces like the trim method we are calling if we use this one. But so that was one of the requirement. Another option was to use the flat map. That works too, but it creates a vector. So I thought this may not be as efficient, although it looks simpler than the fold implementation. But it is creating those vectors, and then we have to at the end just collect or combine into a string. The last option is supposed to be the better performance wise. We are still using fold, but the current implementation for the fold is simpler, so it looks kind of same as the Go. But if you want the optimization in this fold method, we are passing the string as a mutable string, the first argument, and then we are reserving or increasing the string buffer to the length of the new string that is coming in. So we are basically injecting the new string in the old string. So we are not like keep building more string objects and concatenate. So this is supposed to be, as per my when I looked up on the internet, should have better performance, but this seems to require more work. Okay, so before I run this program, I made minor adjustment. I don't know how I missed it the first time. So I moved the loop up here on the top, if you can see right here on line 112. It was below let user input before, so I want to reinitialize the variable and take the user input on every loop. It was outside before, so loop was just running infinitely. Okay, so after we made that change, let's go and execute the program. So our expectation is that it will parse the HTML and return results, href and text without extra spaces in the text, removing any comments and not bringing any tags. So let's run it. So let's start with number one. So for first one, it is simple. We have two href, other page and page 2, and the text. So let's go check it out. So as we can see, there was some span tag in the other page, a link to other page, some span. So it did remove that, so that's good. Let's try the fourth one now. So in the fourth one we had a comment. So if I scroll down to the fourth one, so this is the fourth one. So we have dog, cat, and then we have a comment. So we should skip the comment. So let's see. So we did skip the comment. There are no extra spaces, and the href is dog, cat. So, and at the output is also the link object. So everything looks good, and we can exit the program, and that is it. I will upload the code to modified code to the GitLab, and links will be in the video description. Thank you for watching, and see you in the next one. Bye.